Lesson 3.4, we will study the distance formula, midpoints, and slopes. These all relate to some algebra things that cross over with geometry. So a point's location in a plane is described using an ordered pair of coordinates, where you have your x term first and then your y coordinate, measured from a reference point called the origin along the x-axis and y-axis. Those are two perpendicular number lines that separate a plane into four quadrants. So let's just take a look at this. So we have an x-axis and a y-axis. So the horizontal is the x-axis and the vertical is the y-axis. And we can locate points on here. We have the four quadrants: first, second, third, and fourth. And we can locate points on here. So if we can have a point up here, this might be x sub 1, y sub 1, and there could be a point over here. We might call that x sub 2, y sub 2. Points all over the place. Well, the distance formula, the distance d between any two points, A and B, so we'll call this point A, that's our x sub 1, y sub 1, and point B, is given by the formula, and here is the formula. D equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Well, why does it work out this way? Let's take a look at this. We want the distance between these 2 points. So we want this distance. Well, what we end up doing is we connect a horizontal and a vertical segment to make a right triangle. And if we look at this distance, I'm going to try to get rid of a couple things here. If we look at the distance from here to here, that's actually, the x value here is x sub 1, so that's going to be x sub 1 minus x sub 2. That's the distance from here to here. And then similarly, the distance, the vertical distance, is going to be the y value minus the other y value. You're finding a difference in y values. And now that we have that, we actually notice that we have a right triangle here. And we know that in a right triangle, a leg squared plus a leg squared equals the hypotenuse squared. That is the Pythagorean theorem. So c squared equals a squared plus b squared. Our c, though, is our distance. So the distance squared equals, well, this would be our a. So x sub 1 minus x sub 2 squared plus, and this would be b up here, b, the length of that leg, and that would be y sub 1 minus y sub 2 squared. And then we could take the square root of both sides to get the distance formula. So that's why that works out that way. So there's an example here. Find the distance between negative 2, 5 and 4, 1. Well, we can just put that right in the distance formula. So distance equals the square root of x sub 1 minus x sub 2 squared. It's x sub 1 minus x sub 2 plus y sub 2, which is 5, minus y sub 1 minus y sub 2, minus 1 squared. And that's going to equal negative 6 squared. Negative 6 times negative 6 is 36, plus 5 minus 1 is 4 squared, which is the square root of 52. Now, if you took Algebra 2, you might remember how to simplify this. This is the square root of 4 times the square root of 13, which is 2 root 13. It's about equal to 7.1. So this answer is acceptable. This is better. This is an approximation. So that's how you use the distance formula. Just plug it in. The midpoint formula. So if you have 2 points, A and B, kind of like before, here's A And here's b. It's going to be x sub 1, y sub 1, and this is x sub 2, y sub 2. The midpoint will be given by, the midpoint is going to be x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. That is the formula. Why does that work out? Well, really what we're doing is we're finding the average of the horizontal distance. So that's the average of the x's. Well, to find the average, you add them together, divide by 2. And then we find the average of the y values. So that's adding the y values together and dividing by 2. So that's a nice, easy formula as well. There's an example. Find the coordinates of the midpoint of xy, given that x is at negative 2, 3, and y is at 1, 5. Those are the same points. No, they're not the same points as before. So midpoint. The midpoint will be at the average of the x's. So negative 2 plus 1 over 2. And the average of the y's, 3 plus 5 over 2. And so this is going to be negative 1 over 2 and 8 over 2. And we simplify that 8 over 2 to 4. So there's the midpoint. This next one, example, it says find the coordinates of B if M at negative 1, 1/2 is the midpoint of segment AB and A is located at negative 3, 4. There's a couple different ways to think through this. There's kind of like an algebra way to think through it. We have our midpoint formula. The midpoint equals the average of the x's and the average of the y's. The thing is, we know the midpoint. The midpoint is negative 1, 1/2, and we can say that was our midpoint, and that's equal to one of the x values. So here's x sub 1, negative 3, plus the value we're missing because we're trying to find the coordinates of B. So negative 3 plus x over 2. And then the y value, 4 plus the y value we're looking for, plus 2. And you could put little subscripts of 2 here if you want. Now all we need to do here is, this right here is going to be our x value. So we make a little equation. Negative 1 equals negative 3 plus x sub 2 over 2. You can solve that, multiply both sides by 2. And we get negative 2 equals, the 2 cancels here, negative 3 plus x sub 2. Add 3 to both sides, so the x value of the point we want is 1. And then we can also find the y value because 1/2 has to equal 4 plus y over 2. 1/2 equals the 4 plus y sub 2 over 2. Again, we can multiply both sides by 2. That will cancel, and we get 1 equals 4 plus y sub 2, subtracting 4 from both sides gives us y sub 2 is equal to negative 3. And so the point of B is 1, negative 3. So that's a little bit longer way to do that. There is a bit of a quicker way, which I know we don't have a lot of room here, but we can just kind of generically pick A and B. This isn't necessarily going to be in the right order, but let's say here's A, here's B, and here's M. Well, that wasn't an M. Here's M. Well, we know M, or A, is at negative 3, 4. And we know M is at negative 1, 1/2. Well, we can travel to M by going from negative 3 to negative 1. So from -3 to -1 is 2 units. So we want to keep going 2 more units to get to B. Well, 2 more units from -1, 2 more units would be at 1. And then vertically, 4 to 1/2, that's subtracting 3.5. 4 to 1/2, that's 3.5 spaces apart. So if we kept going, subtract 3.5 again. So 1/2 minus 3.5 would be at -3. And there we have that point once again. The last thing we're going to look at in this lesson is slope. The slope of a line, we call it M, is the ratio of the rise, which is the vertical change, over to its corresponding run. So slope is rise over run. And we use rise over run when we're dealing with the actual graph oftentimes because we can count things off. So down here, if we have this line in example 4, part A, it says find the slope. What we try to do is we try to find some convenient points, so points that cross over the grid. And then we want to think, well, to get from one point to the other, our rise is actually down 3. So rise is -3, and the run is 4. And so the slope of that one is -3/4. Just to so you see this, we could have chosen maybe this point and this point, those 2 green ones. It still will work out. And let's actually start with this one here. Our slope is going up 1, 2, 3, 4, 5, 6. So our rise is 6. And then we're going back 1, 2, 3, 4, 5, 6, 7, 8. So -8, which reduces to 3 over -4, which a positive divided by a negative is negative. So -3/4. So pick 2 convenient points and count it off. Find the slope of a line through 1, -4, and 3, 2. Well, there's another formula or a way to think through this. We use this when we're talking about a graph or referring to a graph. But if we're just given a couple points, the slope is going to be y sub 1 minus y sub 2. We didn't really need the parenthesis there. Over x sub 1 minus x sub 2. It's our change in y values over the change in x values. And so if we're given 2 points, we can just do y sub 1, so -4, minus 2 over x sub 1 minus x sub 2. And -4 minus 2 is -6. 1 minus 3 is -2. -6 divided by -2 is 3. So the slope of that line would be 3. Some facts about slope. When moving from left to right, lines with positive slopes slant up. So going from left to right, so this one would have a positive slope. It goes up left to right, and negative slope goes down left to right. Slope of a horizontal line is 0. The slope of a vertical line is undefined. Parallel slopes postulate. Non-vertical lines are parallel if and only if they have equal slopes. We will use that later, but we know that parallel lines have equal slopes, and that it did discount non-vertical because they have an undefined slope, but it says in this next sentence, any 2 vertical lines are parallel. And then perpendicular slopes. Non-vertical and non-horizontal lines are perpendicular if and only if their product of the slopes is -1. Another way I like to think of this is their slopes, I made that one word there, are negative reciprocals. So for example, if one line has a slope of 2/3, the perpendicular line, the slope of a perpendicular line would be opposite or negative reciprocal. So you change the sign. So our first one over here was positive 2/3. We want to be negative, and then we flip it negative 3 halves. Use the following points to determine whether each pair of lines is parallel, perpendicular, or neither. So all we're going to do is we're going to check the slopes, because if they're parallel, they'll have the same slope. If they're perpendicular, they'll have negative reciprocal slopes. So let's check line AB. So here's AB. And so the slope of AB will be y sub 1, 4 minus y sub 2, over x sub 1 minus x sub 2. Well, that gives us 2 over negative 6, which is negative 1/3. And then the slope of line CD. CD, well, that's y sub 1, negative 4, minus y sub 2, so be careful of this, it's minus negative 3, over x sub 1 minus x sub 2, so minus negative 2. We know that these become a plus. Oops, I got a little carried away here with my negatives. This was supposed to be minus negative 2, so this becomes a plus. This is negative 1 over 3. Well, they are the same, so line AB, since they have the same slope, is parallel to line CD. Line AE, so I'm going to erase all this just so we can start fresh here. We're going to look at slopes again. Slope of line AE. A, so that's 4 minus 3 over x sub 1, negative 3, minus 0. So that's 1 over negative 3. And then the slope of line BC. B, so that's 2 BC minus negative 4 over 3 minus 1. Well, that is 6 over 2, which is 3 over 1, or just 3. And we see that these are opposite reciprocals, so line AE is perpendicular to line BC. And there you have it.